Welcome to today's journey into the unknown. We're diving straight into one of the most mysterious and fascinating objects in the universe, the black hole. What are they? Monsters of gravity? Cosmic gateways? Or hidden libraries of the universe's darkest secrets?
And think about this. When you hear the words black hole, you probably imagine a giant cosmic vacuum cleaner sucking everything in. But the truth is even stranger. A black hole isn't just a dark pit in space. It's a place where space and time themselves collapse.
Exactly. Scientists say the gravity inside a black hole is so extreme that even light, the fastest thing in the universe, cannot escape. That's why it looks like a black void. But here's the terrifying thought. The moment you cross the event horizon, the point of no return, there's no way back. Not for matter, not for light, not even for information as we know it.
And that raises the big question. What actually happens beyond the event horizon? Is it pure destruction? Or could it be a bridge, what physicists sometimes call a wormhole, leading to another universe, another dimension, another timeline?
NASA and other space agencies have been chasing this mystery for decades. When the Event Horizon Telescope captured the first image of a black hole in 2019, humanity saw the glowing ring of light around a shadow, the famous supermassive black hole in the galaxy M87. It was proof that Einstein's theory of relativity still holds, but it also opened up even deeper questions.
Like, what's at the core? Is it a singularity, a point of infinite density where physics breaks down? Or is it something else entirely, something we don't even have the mathematics to describe yet? Some scientists suggest that instead of a singularity, the center might contain exotic states of matter, or even the seeds of new universes.
Imagine this for a moment. Every black hole in the cosmos could be a gateway, a doorway where everything that falls inside is crushed, rewritten, maybe even reborn somewhere else. If that's true, then black holes aren't just the end of stars. They might be the engines of creation themselves.
And here's another mind-bending idea. Time inside a black hole doesn't flow like it does for us. As you approach the event horizon, time slows down dramatically due to the extreme gravity. To an outside observer, it looks like you're frozen forever on the edge, never falling in. But from your perspective, you plunge straight through. This paradox of time is one of the most puzzling and beautiful aspects of black holes.
Which brings us to the possibility of time travel. Could black holes be the ultimate time machines? Theoretically, if they connect different points in space-time, stepping through one could mean emerging in the distant future or the distant past.
But there's a danger in even imagining it. The tidal forces inside would stretch you into what physicists dramatically call spaghettification, being stretched thinner and thinner until your atoms tear apart. It's both horrifying and awe-inspiring to think about.
Still, humans are explorers. We look at the night sky, at these silent cosmic giants, and we don't just see danger. We see possibility. Black holes could hold the answers to the deepest questions. What is the true nature of reality? Where did the universe come from? And could there be other worlds hidden in the darkness?
Astronomers have found black holes everywhere, from stellar mass black holes formed by collapsing stars to supermassive black holes at the heart of nearly every galaxy, including our own Milky Way. That means, right now, at the center of our galaxy, there's a monstrous black hole called Sagittarius Asterix, quietly shaping everything around it.
Think about that. Our solar system, our planet, our very lives are moving in a cosmic dance influenced by this invisible giant. And yet we barely understand it. Black holes are like silent rulers of the universe, hidden but all-powerful.
And maybe, just maybe, they're not just cosmic monsters, but cosmic storytellers, holding the record of everything they consume, matter, light, information. If only we could unlock their secrets.
So what are black holes really? Are they the end of everything or the beginning of something far greater? When we talk about black holes, we're really talking about the limits of human knowledge. They sit right at the edge of physics, where Einstein's relativity collides with quantum mechanics. Two theories that explain the universe perfectly until we get to the singularity where both break down.
Exactly. It's like the universe is teasing us, saying you've come this far, but the real truth is hidden deeper. And that truth might involve quantum gravity, something we still don't fully understand. Some researchers believe black holes could hold the key to uniting all physics into a theory of everything.
Stephen Hawking once said that black holes aren't completely black. They actually glow faintly with something called Hawking radiation, tiny particles escaping from the edge. If that's true, black holes could eventually evaporate over trillions of years. Imagine that, these cosmic monsters slowly dissolving into nothing.
But that discovery also sparked the information paradox. If black holes evaporate, then all the matter and information they swallowed, where does it go? Is it gone forever, erased from reality? Or is the universe somehow storing it in ways we can't yet detect? Because if information can truly be lost, that would rewrite the very laws of physics.
And here's where it gets even stranger. Some theories suggest that black holes could actually be holograms, encoding all the information on their surface instead of inside. This idea connects to the holographic principle, which says maybe the entire universe works this way. What we see as 3D reality might be a projection of deeper physics.
So in a sense, black holes might not just swallow information, they might rewrite the rules of reality itself. And if the holographic principle is true, then our whole universe could be a kind of cosmic simulation, a grand illusion.
Which brings us back to the question, are black holes gateways? Could falling into one transport you into a parallel universe? Maybe even into the multiverse, a landscape of infinite realities where every possibility exists somewhere.
And that's not just science fiction. Serious physicists, from Kip Thorne to Brian Greene, have explored the possibility that wormholes, bridges created by black holes, could connect different universes. The challenge is, even if such pathways exist, surviving the journey would be nearly impossible with our current understanding of matter and energy.
But think about what it would mean for humanity. If one day we could harness the power of black holes, if we could somehow stabilize a wormhole, it could change everything. Faster than light travel, access to new galaxies, new dimensions, maybe even new civilizations.
It's wild to imagine. Right now, black holes are terrifying cosmic predators, but in the future, they could become the most valuable resource in the universe. Sources of near infinite energy, laboratories for extreme physics, even gateways to immortality if they allow us to escape the limits of time itself.
And yet, they remain silent, invisible, waiting. Somewhere out there, countless black holes are shaping galaxies, devouring stars, bending light and twisting time. And we, fragile humans, are staring at them with telescopes, wondering what secrets they hold.
The truth is, every time we learn something new about black holes, 10 more questions appear. They are the cosmic riddle we cannot stop chasing, the mystery that might one day reveal not just the nature of the universe, but the nature of reality itself.
Think about it. When light itself can't escape, we're not just talking about gravity. We're talking about the limits of our universe's rules. A black hole is like a trap door in the fabric of reality. Once you cross it, everything changes.
And that's what makes them so magnetic, the human imagination. They're not just cosmic monsters swallowing stars. They're keys. Keys to questions like, what happens to time itself? Could black holes connect us to other universes?
Some scientists believe black holes could be portals, wormholes even, linking distant parts of space. It sounds like science fiction, but equations in Einstein's theory of relativity actually allow for it.
But there's a darker twist, information.
According to the laws of physics, information can't be destroyed. But when something falls into a black hole, where does that information go? That's the black hole information paradox, and it's shaken physics for decades.
Exactly. Stephen Hawking himself wrestled with this paradox. He once suggested black holes might leak information through what's called Hawking radiation, tiny bits of energy evaporating into space, carrying fragments of the story of whatever fell inside.
And here's where it gets even stranger. If black holes really evaporate over time, it means they're not eternal. Imagine the death of a black hole, after billions of years just fading away into nothingness. That's the ultimate disappearing act.
Yet before they vanish, they might be the engines that shape galaxies. Our own Milky Way has a supermassive black hole at its center, Sagittarius A star. Without it, our galaxy might not even exist in the same way.
So, in a way, black holes aren't just destroyers, they're creators. They hold galaxies together, they bend time, they may even hide the secrets of the universe itself.
And the deeper we look, the stranger it gets. Black holes challenge our understanding of space, time, gravity, and even reality itself. They are mysteries wrapped in darkness, calling us to keep searching.
Which is why every new telescope, every new experiment is aimed at one question. What are black holes hiding from us? Black holes are not just objects in space. They're cosmic mysteries that challenge our imagination. Every time we think we understand them, new research shows us just how little we actually know. Even NASA scientists admit that black holes are one of the most powerful and unexplained phenomena in the universe.
And people around the world are fascinated because black holes combine two things humans can't resist: fear and curiosity. They're terrifying, yes, but also magnetic. They raise questions about life, death, time, and reality itself. It's no wonder black holes dominate YouTube, documentaries, and podcasts everywhere.
Think about the way gravity works inside them. Gravity's so strong that it bends space-time like a sheet of paper. According to Einstein's theory of relativity, this is possible. But when you add quantum mechanics into the equation, everything falls apart. The rules of science break. Black holes expose the cracks in our understanding of reality.
And that's why Stephen Hawking called them the most mysterious objects in the cosmos. His idea of Hawking radiation shook the scientific world because it showed that black holes aren't eternal, they can slowly vanish. But if they disappear, where does everything they swallowed go? That's the black hole information paradox, one of the greatest unsolved riddles in physics.
Some theories suggest that black holes don't actually destroy information. Instead, they might encode it on their surface, like a cosmic hard drive. This connects to the holographic principle, the mind-bending idea that maybe our entire universe is a hologram, that what we see, touch, and experience is just a projection from deeper layers of physics.
And that opens the door to even bigger questions. Could black holes be the gateways to other universes? Could they lead us into the multiverse, a vast landscape of infinite realities? Scientists like Kip Thorne and Brian Greene have suggested that wormholes, possibly linked to black holes, could connect different parts of space-time.
Imagine stepping into one, crossing the event horizon, feeling time slow to almost nothing. On the outside, you would look frozen in place forever. On the inside, you would fall into the unknown. Maybe you'd reach the center, the singularity. Or maybe, just maybe, you'd emerge somewhere else entirely.
It's both terrifying and inspiring. Black holes could be the ultimate time machines, bending the flow of time and allowing travel across galaxies or even into the future. But they could also be cosmic traps, destroying anything that dares to get too close. The balance between danger and possibility is what makes them so captivating.
And think about our own galaxy. At the center of the Milky Way, there's a supermassive black hole called Sagittarius A star. It's millions of times more massive than our sun. Right now, it's silently pulling stars into orbit, shaping the destiny of our galaxy. We live in its shadow, and most people don't even know it exists.
That's what makes black holes such powerful symbols. They remind us that the universe is not just stars and light, it's also shadows, voids, and mysteries that science still cannot fully explain. They make us ask, what else is out there? What secrets are hidden beyond what we can see?
Let's dive into the question everyone asks. What would happen if a human fell into a black hole? It's called spaghettification. Your body would stretch molecule by molecule like cosmic spaghetti. The gravitational pull is so extreme that your feet would move faster than your head, tearing you apart before you even realize it.
And yet, here's the paradox. From your perspective, as you fall, time slows down. You'd never actually see yourself cross the event horizon. To an outside observer, you would freeze in place, fading into red light, trapped at the edge of forever. That imagery, time stopping, light bending, that's why people are obsessed.
It's the perfect blend of science and imagination, and it links directly to Einstein's relativity. Time itself is not constant near a black hole. Minutes near the horizon could equal centuries far away. That concept is SEO gold. Time travel, bending time, parallel worlds. These are keywords people search every single day.
Speaking of experiments, in 2015, the LIGO Observatory detected gravitational waves, ripples in spacetime, from colliding black holes. That discovery didn't just win a Nobel Prize, it proved Einstein right again. And the term gravitational waves skyrocketed in Google Trends.
And don't forget the Event Horizon Telescope in 2019, the world's first image of a black hole in galaxy M87. That picture went viral instantly. Why? Because for the first time, we saw the unseeable. It wasn't just science, it was history. Perfect fuel for a podcast title, The Day We Photographed the Impossible.
But let's push further. Some scientists suggest black holes might be linked to dark energy, the mysterious force accelerating our universe's expansion. If that's true, then black holes aren't just endpoints, they could be engines of cosmic growth.
Which leads to an even wilder thought. What if black holes are seeds for new universes? Every singularity could be a big bang for a new reality. Imagine our universe could be one branch of an infinite multiverse, all born from collapsing stars. Keywords: multiverse, universe origins, creation paradox. That's how you reach both science fans and casual listeners.
And that's why black holes dominate not just research, but storytelling. They embody the biggest questions. Are we alone? What is time? Is death really an end or a doorway?
These questions aren't just physics, they're universal human questions. They make people click, listen, and share. That's why black holes are the perfect core for a long-form podcast.
When people hear black hole, they think of darkness, destruction, maybe even fear. But the truth is, black holes are the most powerful laboratories in the universe. They teach us about relativity, quantum mechanics, even the edge of time itself.
And that's why they dominate science podcasts, documentaries, and even trending searches. People crave answers about cosmic mysteries. Just search universe secrets, time travel, parallel dimensions. Black holes appear everywhere.
Think of it this way. A black hole is like a cosmic paradox. It's invisible, yet it reveals itself through its gravitational pull. It bends light, it distorts time, it makes reality unstable. That's not just science, that's the stuff of legends.
Exactly. And audiences love the what-ifs. What if black holes lead to another universe? What if they hold the key to time travel? What if inside a black hole is a blueprint of creation itself? These aren't just theories, they're the hooks that keep listeners locked in.
You know what's even crazier? Some astrophysicists suggest our entire universe may have been born from a black hole in another universe. Imagine that. Our Big Bang was just a ripple from a bigger cosmic chain reaction.
That idea breaks the internet every time it's mentioned. It blends science with imagination, and that's exactly what spreads on YouTube, Spotify, everywhere. People don't just want dry facts, they want wonder.
And that's why black holes trend. They're not just astronomical objects. They're stories about beginnings and endings, creation and destruction, life and death. Every culture loves those dualities.
Which is why this episode isn't just a conversation, it's an invitation. An invitation for listeners to explore the deepest questions. Where did we come from? Where are we going? And could black holes hold the answers?
And every time someone searches cosmic secrets, dark matter, space exploration, multiverse theories, we'll be right there. Because black holes are the beating heart of modern cosmic storytelling.
They're the universe's greatest cliffhanger.
When we talk about black holes, we're not just talking about distant objects floating in the darkness of space. We're talking about the ultimate mystery of the universe. Places where gravity, time, and reality collapse into something we can barely imagine.
And that's why people are obsessed with them. On YouTube, in books, in podcasts, black holes dominate because they combine everything humans love: fear, awe, and the dream of discovery. They're the monsters of the universe, but maybe also the gateways to something greater.
Let's start with the basics. A black hole is born when a massive star dies. After burning through its fuel, it collapses under its own gravity, squeezing all that mass into an unimaginably small point called a singularity. Around it lies the event horizon, the point of no return. Once you cross it, nothing, not even light, can escape.
And here's the strange part. To us, black holes look like invisible voids, but they're actually shaping the cosmos. They bend light, distort time, and even control the orbits of stars. At the center of almost every galaxy, including our Milky Way, there's a supermassive black hole. In fact, ours is called Sagittarius A star. It's 4 million times more massive than the Sun, silently pulling everything around it into a cosmic dance.
NASA scientists have studied Sagittarius A star, but it still feels like a shadowy ruler of the galaxy. Think about that. Right now, every star we see in the night sky, every planet, even our sun, is moving under the influence of this hidden giant. We live our lives, build our civilizations, without realizing there's a massive black hole shaping our destiny.
And yet we barely understand what black holes really are. Einstein's theory of relativity predicts them perfectly. But when you bring in quantum physics, everything collapses. The rules don't fit together. Black holes are where our science breaks, where the universe hides its deepest secrets.
That's why Stephen Hawking became so fascinated by them. He discovered that black holes aren't completely black. They emit a faint glow of particles, what we now call Hawking radiation. Over unimaginable timescales, this means black holes can actually evaporate and disappear. But that leads to a terrifying question. If they vanish, what happens to all the matter and information they swallowed?
That's the information paradox, one of the greatest mysteries in physics. Does information get destroyed forever, violating the laws of science, or does the universe hide it somewhere we can't see? Some scientists believe that the information is stored on the surface of the black hole, like a cosmic hard drive. Others think it may leak out slowly in Hawking radiation, but nobody knows for sure.
And then there's the mind-bending holographic principle. It suggests that maybe everything inside a black hole, the stars, planets, even entire galaxies it consumed, could be encoded on its surface like a hologram. And if that's true, maybe the entire universe itself is a hologram. What we see as 3D reality might just be a projection from deeper physics.
That's not just philosophy, it's cutting-edge physics. If the holographic principle is real, black holes aren't just objects. They're clues to the true nature of reality. They might prove that our universe is a kind of simulation, or at least something far stranger than we can imagine.
And that's not the only wild theory. Some physicists suggest that black holes could be gateways, wormholes connecting different parts of space-time. If you fall into one, you might emerge somewhere else entirely. Another galaxy, another universe, another dimension.
That's the dream of time travel, too. Near a black hole, time slows down dramatically. To an outside observer, you'd look frozen at the edge. But from your perspective, you'd fall right in. Some scientists believe this means black holes could allow us to step into the future or even into parallel universes.
But there's a danger. The forces inside are unimaginably violent. As you approach the singularity, gravity stretches you in one direction and crushes you in another. Physicists call it spaghettification because you'd be stretched thin like a strand of spaghetti before being torn apart atom by atom.
It's horrifying, yes, but it's also inspiring. Because black holes show us that the universe is far bigger, far stranger than anything we see on Earth. They force us to confront questions about the origin of the universe, the nature of time, and the future of humanity.
And think about this. If black holes really are gateways, then maybe they are the birthplaces of new universes. Some scientists believe that inside every black hole, a new cosmos is born. If that's true, then maybe our universe began inside a black hole in another universe, a cycle without end.
That means every black hole could be a cosmic seed, planting new realities, shaping an endless multiverse, a chain of creation and destruction where black holes are not just the end of stars, but the beginning of worlds.
And here's the haunting part. We may never know. The event horizon is a perfect wall. Once something crosses it, the information is hidden. We can only stand at the edge, staring into the darkness, wondering what lies beyond.
But humans are explorers. We've always chased the unknown, from crossing oceans to landing on the moon to sending probes into the outer solar system. Maybe one day, with enough courage and technology, we'll find a way to study black holes up close. Maybe one day we'll step across the event horizon ourselves.
Until then, black holes remain the greatest mystery of all. Silent, invisible, powerful, and waiting for us to uncover their secrets.
Imagine standing at the edge of reality itself, a place where time slows, space bends, and light disappears forever. That's the world of black holes.
They are not just cosmic monsters. They are puzzles, paradoxes, and perhaps the keys to understanding the ultimate secrets of the universe.
A black hole forms when a massive star collapses under its own gravity. The core shrinks into an infinitely dense point called the singularity. Surrounding it is the event horizon, the point of no return.
The term point of no return always captures people's imagination. Once you cross it, nothing, not even light, can escape. It's a one-way trip into darkness.
And that's why they're called black holes. Invisible, silent, yet unimaginably powerful.
So let's ask the big question. What if a human fell into a black hole?
2 words, spaghettification process. Your body would stretch vertically and compress horizontally, torn apart atom by atom. It's gruesome, but fascinating.
But here's the paradox. From your perspective, time would feel normal. From our perspective, you would freeze at the event horizon, forever suspended in red light.
That image, someone frozen at the edge of eternity, feels like poetry. And it's pure physics.
Black holes prove Einstein right. Time is not absolute. Gravity bends time itself. Near a black hole, minutes could equal centuries outside.
That's why black holes are linked to time travel theories. Search time dilation or relativity in black holes, and you'll see millions of results. It's one of the strongest hooks for audiences. What if black holes allow us to travel through time?
In 2015, scientists made history. They detected gravitational waves for the first time, ripples in space-time caused by colliding black holes.
That was huge. It confirmed Einstein's predictions a century later, and the internet exploded with searches, gravitational waves, LIGO, space ripples. Those waves prove black holes aren't just mathematical ideas, they're real, violent, and powerful.
Then came 2019. The Event Horizon Telescope captured the first image of a black hole in galaxy M87.
A blurry orange ring, but historic. For the first time, humanity saw the unseeable. That picture spread faster than any space discovery in modern history, because it wasn't just data, it was a symbol, proof that we can reach into the abyss and pull back a glimpse of the truth.
Now let's go deeper. Some physicists suggest black holes might be connected to dark energy, the force that accelerates the expansion of the universe.
If true, black holes aren't just destroyers, they're engines of growth. They could be shaping the cosmos on a scale we can't even imagine.
And here's the wildest theory. Black holes might be gateways to new universes.
Every singularity could spark a new Big Bang. Our universe might just be one child in an infinite cosmic family tree.
That ties into the multiverse theory, one of the hottest SEO keywords in science. People love the idea that black holes are doorways, not dead ends.
The reason people can't stop searching for black holes is simple. They embody mystery.
They challenge our most basic ideas. What is time? Can information disappear? Is death final? Or could it be transformation?
Every culture, every myth has versions of these questions, and black holes give them a modern scientific stage.
Chapter 9. The future of black hole exploration.
With telescopes like the James Webb and future projects like the Einstein telescope, we're only scratching the surface.
Someday, we might map the interiors of black holes or even test whether they are portals to other dimensions.
And when that day comes, the questions will get even bigger. People always ask me, why are black holes the most talked about objects in the universe? And the answer is simple. They combine fear, beauty, and mystery all at once. They're invisible giants, swallowing light, distorting time, and making the universe itself feel alive.
And that's exactly why audiences are obsessed. Search black hole mysteries, universe secrets, or time travel possibilities, and you'll find millions of people searching, listening, and watching. Black holes are like magnets for curiosity. They pull in science lovers, conspiracy fans, dreamers, and even people who just want to imagine the impossible.
Think about what happens near the event horizon. To an outsider, time slows down until it almost freezes, but to the person falling in, nothing feels different. That paradox, two realities at once, is why words like time dilation, relativity, bending space, parallel worlds trend so high online. They're not just physics terms, they're storytelling fuel.
Exactly. And the more we explain it, the more people realize black holes aren't just science. They're gateways to imagination. Are they portals to another universe? Could they connect two distant points in space, like a wormhole? These ideas are scientifically possible, and that's what keeps people engaged. It's not fantasy, it's science on the edge.
And we've already seen proof of their power. The gravitational waves detected in 2015, ripples in space-time caused by black holes colliding, literally changed the way we study the universe. The words gravitational waves, LIGO discovery, cosmic ripples became instant keywords across news, podcasts, and YouTube. People were fascinated because, for the first time, we didn't just see black holes, we felt them.
And then came that photograph in 2019, the first ever image of a black hole. Billions of shares, trending hashtags, and a collective gasp from humanity. That picture wasn't just data, it was proof that the impossible could be captured. It told the world, black holes aren't just theories, they're real, and they're watching us from the darkness.
What makes them even more captivating is how they link to bigger mysteries. Some scientists believe black holes could explain dark energy, the invisible force that drives the expansion of the universe. If that's true, then black holes are not just destroyers, they're creators, shaping galaxies and fueling cosmic evolution.
Which naturally leads us to the multiverse. Imagine if every black hole births a new universe. Our universe itself could be the child of a black hole in another dimension. Words like multiverse, alternate realities, new universes spark people's imaginations instantly. And these aren't just sci-fi ideas. They come straight from equations and leading astrophysicists.
And this is why black holes dominate podcasting, YouTube videos, and trending science discussions. They bring together the biggest questions humans ask. Where did we come from? Where are we going? What is reality? Are we alone? And is death truly the end, or just the beginning of something else?
They're the universe's ultimate cliffhanger, a mystery that never ends, always pulling us deeper, always keeping us searching. And the more we search, the more questions we find. That's why black holes will always remain at the center of human imagination.
You know, whenever we start talking about black holes, I always feel like we're standing at the border of science and myth. They're not just astrophysical objects, they're symbols of the unknown, and that's why people can't stop searching for them. Type black hole on YouTube, Spotify, or Google, and you'll see millions of results. Cosmic mysteries, space exploration, time travel, multiverse theories, Hawking radiation. It's proof that these objects dominate the collective imagination.
That's because they bring together every element humans are fascinated by. Death and rebirth, creation and destruction, fear and wonder. They're nature's paradox machines. On one side, they swallow entire stars. On the other, they may seed galaxies or even new universes. Just think of the keywords tied to them: universe origins, dark energy, relativity, parallel worlds. These aren't just physics concepts, they're hooks that make people listen, watch, and share.
And the moment you try to imagine what happens at the event horizon, you realize why they're so captivating. To you, the falling traveler, nothing feels unusual. But to an outside observer, you freeze in time, fading into red light, suspended forever at the edge. That paradox alone fuels endless discussion. It's no surprise that time dilation, relativity explained, edge of time trend so high on platforms like YouTube and TikTok.
Right, and when people ask, what happens if a human actually falls into a black hole, that's when the story becomes irresistible. Spaghettification. molecules stretched apart, pulled to infinity. It sounds terrifying, but also cinematic. That's why videos with titles like, "What if you fell into a black hole?" hit millions of views. It combines scientific accuracy with horror and curiosity.
But the real treasure lies in the questions that black holes force us to ask. For instance, does information survive inside? Stephen Hawking wrestled with that paradox his entire career. According to physics, information cannot be destroyed, but black holes seem to erase everything. His groundbreaking idea that they leak tiny bits of information through Hawking radiation made him a legend. And that phrase alone, Hawking radiation, is one of the most searched science terms online.
Hawking changed the conversation. He made people realize black holes aren't eternal. They could slowly evaporate over billions of years, disappearing in bursts of radiation. Imagine that, the death of a black hole. For something we thought eternal, that's mind-blowing. And when podcasts or videos use phrases like the end of black holes, they instantly draw clicks because they flip the script.
And Einstein, long before Hawking gave us the foundation, his general theory of relativity predicted black holes before we ever saw them. Equations written on paper led to the discovery of objects millions of light years away. That's why Einstein relativity, black hole proof, bending spacetime are keywords that never die out. People still love connecting the genius of Einstein to the mysteries we're only now proving with technology.
Technology is the bridge. Look at LIGO's discovery of gravitational waves in 2015. Two black holes colliding, sending ripples through spacetime. That wasn't just science, that was history. Headlines like, "We heard black holes collide," went viral. It turned abstract physics into a real, measurable event. And those ripples literally shook the internet.
And then 2019 came, the year humanity saw the unseeable. The first image of a black hole in Galaxy M87. A blurry orange ring, yet the most iconic photo in modern astronomy. It trended globally in hours. Because humans love symbols, and that picture was a symbol of victory against the unknown. Titles like First Photo of a Black Hole or Seeing the Impossible are magnets for viewers.
But the fascination doesn't stop there. The theories keep getting wilder, and that fuels content creation. Some scientists suggest black holes might be tied to dark energy, the mysterious force accelerating the universe's expansion. Imagine the clicks on a title like, "Are Black Holes Powering the Universe?" It merges two of the most mysterious concepts into one irresistible question.
And let's not forget the multiverse theory. If black holes birth new universes, then every singularity could be a cosmic womb. Our Big Bang might have been the final sigh of a collapsing star in another reality. That idea, new universes, alternate realities, multiverse portal, has limitless appeal. People crave that blend of science and philosophy. It's not just physics, it's existential storytelling.
And that's the heart of it. Black holes let us ask questions about meaning. Is death really the end, or is it transformation? Can something that disappears completely still leave behind echoes of information? Can destruction lead to creation? Those aren't just physics puzzles, they're human stories. And human stories spread.
That's why black holes dominate every platform. Podcasts, YouTube, books, Netflix documentaries, they all come back to these same mysteries because they guarantee curiosity, conversation, and endless speculation. From time travel to quantum gravity, from Hawking's paradox to Einstein's relativity, the keywords line up with what people are already searching for.
Exactly. And when we talk about them, we're not just giving information, we're feeding the natural hunger humans have for wonder. That's why black holes are the ultimate topic for long-form podcasts. They're timeless, trending, and deeply human.
They are the universe's greatest cliffhanger, and the more we study them, the deeper the mystery grows.
Which is why this conversation will never end. Every answer we find in black holes leads to 10 new questions. And those questions are what keep listeners coming back, episode after episode, eager to hear the next chapter of the cosmic story.
You know, every time we talk about black holes, I get this strange mix of fear and fascination. It's like staring into an infinite abyss, and yet we can't stop looking. Do you think that's why people are so obsessed with them? Because they're not just cosmic objects, but symbols of mystery itself.
Exactly. Black holes are like nature's ultimate cliffhanger. They represent the limits of our understanding, places where our most trusted laws of physics seem to break down. People crave that sense of the unknown, the possibility that there's something bigger, darker, and more powerful than anything we've ever experienced. It's the perfect mix of science and storytelling.
And the way we describe them. Gravity so strong that not even light can escape. It sounds like something out of a myth, but it's real. A black hole isn't just theory anymore. We've seen the shadow of one, thanks to the Event Horizon Telescope. That image went viral because it wasn't just a picture, it was proof that the monsters we imagined are truly out there.
And it's wild to think that black holes aren't just devouring machines. They also shape galaxies. They sit at the centers of galaxies, controlling the dance of stars, regulating star birth, and maybe even determining the fate of entire cosmic structures. They're destructive and creative at the same time. That paradox makes them even more compelling.
I think that's what draws people in, the duality. They're both terrifying and beautiful. If you fall into one, you're gone, no escape. Yet, without them, the universe wouldn't be what it is. It's the perfect metaphor for power, mystery, and inevitability.
And then there's the question everyone asks. What happens inside? Is there another universe on the other side? Do the laws of space and time break apart completely? Could a black hole be a doorway, not an end? These are questions that ignite imagination. And honestly, that's why they're perfect for podcasts, because people love to wonder. And black holes give us endless fuel for that wonder.
And the SEO world loves them too. Think about it. Search terms like black hole mystery, event horizon, what happens inside a black hole, space podcast, cosmic mysteries. These words trend because they capture curiosity. Everyone from casual listeners to hardcore science fans wants to hear about the places where our knowledge collapses into uncertainty.
Right, and speaking of uncertainty, scientists are still debating whether information is truly lost in a black hole. That sparks one of the biggest puzzles in physics, the black hole information paradox. If information can't be destroyed, then where does it go? That single question has sparked entire careers, thousands of papers, and endless debates. It's like a philosophical riddle written in the language of physics.
It's the kind of question that makes you lean closer to the mic, drop your voice, and say, "We may never know." That's what keeps listeners hooked, not the answers, but the mysteries that linger.
And don't forget the emotional pull. People imagine what it would be like. Falling in, stretching into spaghetti, time slowing to a crawl. It's terrifying but irresistible. The idea that black holes are not just faraway phenomena, but possible futures for stars, for systems, maybe even for us. That sense of inevitability resonates deeply.
Exactly. It turns science into an existential story, and that's why, if we keep digging, keep asking, and keep weaving these mysteries into our conversations, people will always want to come back and listen. Because black holes aren't just astrophysics. They're the closest thing science has to poetry written in darkness. You know what I find fascinating? The idea that time itself gets twisted near a black hole. If you were hovering close to the event horizon, time for you would slow down compared to someone far away. That means, in theory, you could see the future of the universe play out while only moments pass for you. It's like black holes are not only monsters of gravity, but also time machines.
That's what makes them so powerful in both science and imagination. People type into YouTube and Google all the time, black hole time travel. Do black holes bend time? Black hole explained simply. These are some of the hottest search terms because everyone wants to understand the impossible. It's not just curiosity, it's the hope that black holes might unlock secrets about our past and future.
And let's not forget the sound of them. NASA once released audio of waves detected around a black hole, and it was eerie, like a cosmic growl, a low vibration from the edge of eternity. That clip went viral because it wasn't just theory anymore. It was something you could hear. People love that mix of science and sensory experience. It makes the cosmos feel real, almost alive.
That's true. And the fact that black holes collide.
That's another magnet for attention. Two massive black holes spiraling into each other, creating ripples in space-time called gravitational waves. That discovery in 2015 made headlines worldwide. Imagine telling listeners, every time you hear about gravitational waves, you're literally hearing the universe ring like a bell after two monsters collide. That image sticks in people's minds.
Exactly. It's cinematic. And what's amazing is that all these terms, gravitational waves, merging black holes, cosmic ripples, are not just science, but also SEO gold. They are high-ranking keywords because they connect science lovers, space fans, and even people who just want to hear a good cosmic mystery.
And the questions keep coming. Could a black hole create a wormhole? Could it connect to distant parts of space or even two universes? Physicists debate it, science fiction writers embrace it, and audiences love it. The idea of stepping through a black hole into the unknown is pure storytelling fuel.
And think about this. The biggest black holes, called supermassive black holes, can be billions of times heavier than the sun. They sit at the hearts of galaxies, including our own, Milky Way. The one in the center of our galaxy, Sagittarius A, is like a silent ruler. It's invisible, but everything around it dances to its pull. It's like the universe's ultimate hidden king.
Which is why people search black hole at the center of the Milky Way or supermassive black hole explained simply. They're not just searching for facts, they're searching for awe, for something that makes them feel small and amazed at the same time. That's the emotional connection, making people feel part of the cosmic story.
And here's something even wilder. Black holes might not be the end. Some scientists believe that when a black hole evaporates through Hawking radiation, it could release hidden information back into the universe. Imagine if black holes are not just destroyers, but secret keepers, guardians of cosmic memory, waiting to whisper it back when they die.
That's the kind of line that makes people lean in, hit replay, and share. It blends science, mystery, and poetry. And for podcasts, that's perfect. Because it's not just about delivering facts, it's about sparking imagination, raising goosebumps, and making the universe feel closer.
And that's why we'll never run out of things to say about black holes. They are endless mysteries, bottomless wells of curiosity. The more we learn, the more questions they create. And that's why listeners keep coming back.
You know, the deeper we dive into the mystery of black holes, the more they feel like mirrors of our own curiosity. They're silent, invisible, and yet they shape entire galaxies. It's almost poetic, something we can't see holding everything together.
And that's the magic of these cosmic giants. They are terrifying, beautiful, and profoundly humbling. Every scientist, every dreamer, every listener comes to the same point. We are tiny pieces of a vast, living universe, and black holes remind us of that truth in the most dramatic way.
That's why people will always search, always listen, always wonder. Whether it's what happens inside a black hole explained, are black holes portals, these questions keep trending because they tap into our deepest need to understand where we come from and where we're going.
Exactly. And the best part? Every new discovery adds another chapter to the story. From gravitational waves to the first image of a black hole to the mysteries of Hawking radiation, it's a never-ending journey.
And that's where we'll leave our listeners today, on the edge of the unknown, standing at the event horizon of human knowledge. Because when you look into a black hole, you're really staring into the future of science itself.
Thank you for being with us on this journey. If you felt the same awe we did, remember to follow, share, and stay tuned, because the universe still has countless secrets waiting to be uncovered.